Okay, I think we should get us started. So welcome to the Madinas session. I'm Carlos Bernardos and Juan Carlos Zúñiga is online. So let's get started. Not well, I guess you are all familiar with the not well. In any case, if you are not familiar with the IETF procedures, please check the relevant documents and how we should deal with IPR and how we should deal with any other things or other things in regarding the way we work at IETF. Regarding IETF, this meeting, some tips. You need to join the Mitico client either from your computer or from your mobile to record your presence, so the blue sheets are automatically filled with your when you log in into the Mitico. You have to use also the Mitico to join the queue, even if you are here locally in Philadelphia. And of course, if you are using Mitico on site, you have to keep the audio and video off while using the on-site version. We had to wear the masks during the meeting, and I would appreciate if we try to keep them on unless you really need to take it off to speak. And for the remote participants, please ensure that your audio and video are off unless you need to present or join the queue. These are the resources for the meeting today. Of course, we have the agenda. We have all the information on Mitico that I hope you have reviewed. We are already on Thursday, so I guess you are all familiar with the procedures. And you have any issues, you have there how to report them. A few reminders. Minutes are taken. Thank you, Michael, for taking some notes. I will appreciate if more people can join the note taking tool. I think it's easier if more people are there to ensure that we collect appropriately all the actions and agreements. A reminder, this meeting is being recorded. As I mentioned, the presence, the blue sheets are automatically filled in if you join the Mitico tool. And we have also the online, the chat that, as you probably know, we are migrating to Zulip. You can join there and also in the Mitico integrated chat part. This is the agenda for today. We'll have a short working group status and agenda review. Then we will have some updates from IEEE activities from Juan Carlos. Then I will briefly update also on the status of the MAC address randomization current state of affairs draft. Then we'll switch to Jerome for an update on the use cases and problem statement draft. These are the two working group items that we have at this point. Then we will have some short updates or news on an roaming experiment, open roaming experiment that is planned, that is being explored with the WBA. Then some next steps and time permitting, hopefully there will be time for that. Non-working group document presentation on a Savvy solution for wireless LAN. Any agenda bashing? Any comments? If not, let me just quickly do we already sent an email about this. We are starting to use GitHub. So we have the GitHub organization created according to the RFSC. So we have one now for the Madinas. You can get to that into the Madinas data tracker information page. There is a link for the additional resources, and there is the GitHub organization there. And if you go there, you will see that there are a couple of repositories, one per working group document that we will be using as RFC 8874 recommends. So basically, we'll use that to keep the documents and manage the issues and editorial recommendations from the working group. This is a learning process. I mean, I have been using GitHub, but I'm not an expert, and I not expect all the people in the working group to be experts on how to use GitHub. But I think it's a good tool to keep track of the text suggestions and recommendations. But it's also important that we will be using or keep using the mailing list for the actual discussion. So we are not moving the discussion to the GitHub. It's not the purpose. The GitHub is an additional tool to facilitate keeping track of some editorial issues and and providing text in a way that is easier for the editors to manage. But it should be a tool to facilitate things, not too complicate, of course. And the discussion should be kept on the mailing list. Any comments? Any? If not, we can switch to the next point in the agenda, which is the updates from IEEE from Juan Carlos. So let me share and let me give you the control.
Thanks, Carlos. Can you hear me?
Yes, loud and clear.
Great. Hi, everyone. Hope you're having a good time in Philadelphia, eating a lot of cheesesteak sandwiches. So this is an update from the IEEE 802.11 meeting that I was able to attend a couple of weeks ago in Montreal. And I think it was important to remind people and give an update about the work in W and 11 BH and BI, especially BH. So 11BH is discussing some use cases where they may need some identifiers, some new identifiers now that they cannot rely on random MAC addresses any longer. And they are mainly going around IT support and captive portal type of use cases. So as you as you remember from the last discussion, the group's still discussing the three general directions. The first one is when an STA or a station, a mobile, in this case, generates a layer 2 ID and passes it on to the AP after association through a secure tunnel, and then foretells the AP if the ID is changing in the future. The second approach is for the AP to generate this ID, or the network to generate the ID and pass it to the station after association. And then the STA will signal whenever there's a new association so that the AP can generate a new one. And the third approach is to exchange keys allowing common computation of this ID so that both know who they are talking to. And the group still discussing these three approaches. There's, of course, pros and cons and different points of view regarding these three approaches. But anyway, I think this is something that we need to keep in mind in our future discussions when we look at the use cases more in detail, as we want to coordinate with IEEE. We don't want to reinvent or do the work twice. And we also we want to complement each other as much as possible. So the other group that is of relevance is 11BI. This group is not looking at new identifiers, but rather examining what elements may have an impact on privacy and how can they be better protected. And in this case, they are talking about obfuscating key identifiers in REST associations, reducing the fingerprint exposure because of multiple options in probe messages and IEs, etc. So it's interesting, but not, I think, as impactful as 11BH. Something that we may want to keep in mind is to continue this discussion. So far, we've been having these updates here about what's going on in 11, but they are less aware of what we plan to do in Madinas, or what we are looking at in Madinas, and the relationships that we are establishing and having with WBA, etc., WFA. So it'll probably be good to keep this conversation more open in the future. Are there any questions? Eric.
It's going to the mic.
Yeah. Looks like a big room.
Oh, looks like Michael beat me to the queue. Why don't you go ahead? My question was, I think if you go back one slide, it said after association. Was there any? Have people given up on what you do about MAC addresses randomization during scanning? Maybe just accepting that it's going to be random when they scan, or Is 802.11 worried about
Uh,
that?
I think I can. Well, I'll take a stab, and then maybe Jerome, I think he's online, can help me out here. But I believe, yeah, the group it's mainly concentrating on ones you have already associated. And for the scanning part, we assume that it's going to be a random address. But I don't know, Jerome, can you give more info?
Yes. So yeah, absolutely. So there are two elements, right? There is the scanning part, and there is the pre-association part. And they make a difference. During scanning, you're just discovering the environment, so they are not looking at trying to give an identifier to somebody who's just discovering. So that is going to stay, at least in the intent of the group, completely private and therefore randomized. However, they are heavily debating right now what they call pre-association steering, where, for example, you want to have an IoT device go to 2.4 and your AR/VR stuff go to 6 gigahertz, which means that the AP needs to be somehow able to identify what kind of device is discovery network to direct this device accordingly. And for now, there are two plans. Those that say it's pre-association, you don't touch it, and those who say you need to provide a better experience, therefore you need to direct correctly. There's you need to know something. They are in the middle of that conversation. It's been going on for about 2.5 months now. I expect a few more months of a heavy battle.
That makes sense. Thank you very much.
Sure.
Michael Richardson, on the same slide. This just sounds an absolutely terrible idea. I guess someone at the IEEE thinks that access points run captive portals, because that's usually not the case. They're usually the captive portal in the layer 2 architecture behind a whole bunch of access points. So mostly the IEEE doesn't own the protocol behind that. It's mostly proprietary. And the IETF owns the captive portal API. So I don't think this is a good place or good group to do this kind of work at the IEEE. I think it's, again, the IEEE believing that there are protocols other than IP, which there aren't anymore. If someone's running DECnet over Wi-Fi, then maybe this applies. But I mean, I just don't see them. This is just a whole bunch of work to me that I don't know why this, and I don't know how to express the frustration of this kind of direction to me. Okay, this is not useful. As for the question of IoT devices and some other stuff, well, I hope that one of the things that this working group is going to do is produce a document which essentially says that in 94% of the cases that home IoT devices should never randomize their MAC address, that it's inappropriate and unsafe. So the only ones that should be randomized are the ones that you carry to and from the Starbucks for some reason. Anyway, I don't know how to get this, Eric, some more clear liaison going on, because I think this is a disaster. And I think it's undeployable. It's an undeployable disaster. And the people that aren't going to be able to deploy it don't go to the IEEE to speak up, to say that this is undeployable. So my feedback here, I don't know how to express it to the IEEE.
Okay. Thanks for the comment. Yeah, indeed, I think that at least from my point of view, they are missing some information about what's going on here, and it wouldn't hurt to open up the channel. And again, Jerome, I don't know if you want to add something, since you've been more active in EH.
Yeah, I mean, I fully agree with all the comments that were made. But just for clarity, what BH PAR also goal or framework is what was working before that is broken now that RCM is in place, randomizing changing MAC addresses. And things they have noticed that are broken is you go back to your room in the hotel and you have to re-authenticate all the time. So that's because of that, they say on their charter. It does not necessarily mean that they are going to produce a solution at layer 2. And the more liaison we can send to them, say, well, There's a hope that IETF can fix that, because in CAPORT, for example, it's not necessarily the MAC address, but the MAC address is one of the items that can be used to identify a station. So the more liaison we can bring to them to tell them the solution will be brought, by the industry outside of layer 2, the better they will be armed to conclude that there is no need for them to do any work there.
Eric Klein again. I just wanted to sort of respond to Michael. I did not take from this slide that they were assuming a capture portal was going to be inside of an AP, but simply that and if Carlos, Juan Carlos, if you said that, then I missed it. But I took from this slide that capture portal is an application, and they consider a repeatable, stable MAC to be a requirement for a capture portal. So I think they're still fairly widely separable problems, but perhaps there's stuff that I don't understand.
Correct.
So Eric, Michael Richardson here again. So if you build a layer 2 protocol that uses the current encryption to update the access point with your new address or your intended new address, okay, if you don't also build a protocol that spreads that all to the control mechanism, the captive portal enforcement point, which may be beyond that, and all the other access points that need to know that, then the problem is that, well, you tell captive access point 1 your new intended information, and then you walk to the other room. And then the other access point doesn't know who you are. So it's not enough to do a protocol between a station and an access point, right? You have to do all of the rest of the infrastructure, and the rest of those protocols are either proprietary or not even known by the IEEE, right? Well, how can it? I mean, you have to do more than that, right? You have to do a lot more than that, is what I'm trying to say, to make a workable solution, okay? And what I'm saying is that I don't think that the protocols that need to be updated are even represented in that group, okay?
Eric Vink. Michael, you know for sure that there is an IEEE IETF coordination mailing list and group that you are meeting sometimes. If not mistaken, you are part of it even. So there's something to be maybe, I wouldn't say escalated, and maybe it's too strong a word, but at least mentioned.
I will do that.
Okay, thank you. Let's move on to the next. It's me, I guess. If you don't mind, I will be presenting from here because otherwise I don't have an easy way to switch the slides. So this is an update on the MAC address randomization state of affairs draft. This is version 02, authored by myself, Juan Carlos, and Amelia. So, well, again, just a quick recap on the introduction and goals. So, well, we know how Madinas, or why Madinas was chartered, and the goal of this draft is basically to document what are the different efforts and activities that are being done on IETF, IEEE, mobile OS vendors, WBA, regarding the MAC address randomization. So that's the overall goal. This is the table of contents. It's the same that that we had in the previous version, and I'm highlighting there section 7, which is basically documenting what the mainstream operating systems are doing regarding random address, random MAC address, and how they use them. And we discussed this in the previous meeting. That was the main point of discussion regarding this draft in IETF 113. And we agreed that since this is the kind of dynamic content that it evolves, because the operating systems are evolving what they do on as they move along, we have moved that to a GitHub content that is basically there. And we have added a link to the GitHub on the draft. And if you see, this is the GitHub content. And we don't know yet if this is the best way of doing this. This is kind of new, but it's a way to do it. So let's try how it works. And I would appreciate if you detect any content that is not accurate. We already had some comments in the previous version pointing out pointing us to some things that we need to modify. Since this is live, if you see anything, you can either contact us, mailing list, Git pull request, whatever you think to keep the document updated and as complete as we think is needed. Then just a quick summary of the different parts of the document. We have one part regarding the activities of at the IETF. This goes back as even IETF 91, where we started to look into this problem and the different experiments that were done in different IETF meetings, as well as related work in different RFCs regarding the anonymization or randomization of some identifiers. Then we have, of course, the activities in IEEE, and JC has just updated us on some of the activities together with Jerome. And we also have the activities as the WBA that, as we have had in past meetings, they are very active and looking into this topic. And of course, we need to be coordinated with them. Then there is this part about the different OS current practices. So we focus on Android and iOS as mobile operating systems, and we try to document what they do in terms of what are the identifiers that they use for scanning, how the identifiers, the MAC addresses that they use when they are associated change depending on whether we switch to a different network or whether we rotate that periodically. These type of practices are trying to be captured there. And we also have some analysis of kind of what we will desktop operating systems like Linux and Windows 10, also documenting what they do at the time that we were doing this test. And this is why this is a part that we want to keep alive as things may change with the new versions of the operating systems. And this is just the changelog. So from the previous version, the main change is to move this section 7 to the GitHub. And again, please, any update or anything that you think we need to cover, let us know. And that's it from my side. Then we can switch to the next agenda item. Any comments?
Any comments for Carlos?
Yes.
This is Daniel Con-Gilmore. Sorry, I didn't press the button. My link is not great. So I'm not sure that I understand the goal of moving the section all the way to GitHub instead of having a point in time and a link to GitHub. Is the idea that when this is published, is the intent to publish this as an RFC?
Yes, the idea is that as we can publish that at some point in the time and things may evolve, we have some part of the document or some part linked to the document that can evolve.
So is the intent, I just want to understand, is the intent to publish the snapshot when this goes out as an RFC that also includes a link to GitHub for the updates?
Yeah.
Okay, makes sense. Thank you.
Yeah.
Michael?
Eric Wenk again. And Daniel, this kind of technique has been approved by the ISG for a couple of cases like this. Because once I receive a carved in stone, right? This one will be stopped to be updated maybe in 10 years only. Yeah.
Michael Richardson. So what I would like to see, and I proposed a pull request against this GitHub, the document in the GitHub, is that we come up with a set of standardized terminology, a taxonomy of the different mechanisms. I don't want to describe, the thing that Android does in 2019. I want to give it a name, okay? And then it simply becomes a question of labeling each thing, and version whatever, blah blah blah, and that's it. And we should have that should GitHub people can do an update, and we might revise the document at some point and pull in another snapshot or something like that. But to me, we should be arguing about the taxonomy, and we should be figuring out whether there's something we've missed, something that someone's thinking of doing but thought was a bad idea, or even something that someone tried and turned out to be a bad idea, right? So we can give it a name and actually say, okay, don't do that, or only do it in this environment, right?
Thanks, Michael. So let's move to Jerome. And I will pass you the control, Jerome.
Thank you. Hello, everyone. So this is an update on the other document that we've been working on, which is the use case document. And as you may remember, by the way, this is the link to the document that is posted now. What this document was about is to try to create a framework around the conversations, exactly to Michael's point a second ago, about putting names on different concepts that we're manipulating and looking at the landscape of what's happening around this RCM and identification. And it's, of course, as you may remember, a little bit complicated because there are multiple type of devices, type of actors, from those who observe, those who act, the network operators, etc. And also different types of environment, from home to enterprise to public venues, etc. So what this document does is to list these different elements that act together and try to define some use cases where RCM is encountered. And to do so, we also try to establish a trust variable, which is typically never set to full trust, but has a range of distrust, depending on environment and who may be observing the communications. So we've been, I'm very short on this because we've been discussing this document for a while now. We stopped last time at V1 when we moved that document from a contribution into a document that the group has adopted. And in V2, what we wanted to do, and that document is posted now, is to look at some solutions that we may see in the industry to address use cases around RCM and identification. As you may remember, at the end of the document, the previous version of the document, the last section was recapitulating some requirements that we discussed in the group and thought that could be applicable to the different use cases. I've put them here so you can go back to them and read them as you prepare questions or as you review this presentation. And there were 8 of them primarily. And as we look into this document and we started looking into the state of the industry, we realized that some of these requirements probably cannot be met today. For example, there is this idea of, let me go back 2 slides ago, on this first requirement that says network should not make any assumption about the client MAC address persistence, which means that the change that MAC address can change at any time. Today, for example, in the 8.2.11 structure, this is not allowed. You cannot change your MAC address and maintain a session. That's going to go away. However, we know that one of the 2 groups that Juan Carlos mentioned, 8.2.11bi, is looking at this idea of session continuity while the MAC address is changing. So that type of requirement might, get onto a new life as progress is made in that group. However, some other of the requirements we think have already been thought about or looked into by some elements of the market. You may recall that in the previous meeting we had the WBA liaison telling us about a white paper they wrote about some scenarios where identification would be possible, needed or not wanted. In particular, one thing they were addressing that we thought would be very useful is this idea that you could have an association that could protect the identity of the user, during which the MAC address will not play any important role anymore, not upstand 11bi, of course, and that would be simply because it would be protected. The connection would be protected by identification of the user, not necessarily the device itself, and the link to the access point would be protected and encrypted. One such protocol is, of course, something we know, it's .1x, .pa2, .pa3, but they were also mentioning an interesting standard that they have been pushing for a couple of years now, which is called open roaming, by which a user can connect to a network, stay anonymous to that network while still being authenticated to a third-party authentication authority, which merely returns to the local venue, this user is valid, although you don't know his data, his details. This user is valid, allowing the user to be connecting while still being private to the vis-a-vis the venue. In that scenario, of course, there is a sort of a possibility of traceability when need be, because we know who is the authentication authority, but the user identity itself will not be exposed. The MAC address itself becomes irrelevant, and therefore the rotation would become possible, either through disconnection and reconnection, which is what would happen today, or if 11bi concludes on its work with a continuity of session. So that's one element that we thought could be useful to our use cases. So in the new version V02 of this document, we have added a section that describes the solution and how we could entail in the different scenarios that we were exploring in the document. This is of course just one. We think that there are plenty of other standards that could be useful for us, plenty of RFCs that could be useful for us to explore, in particular in the world of DHCP, EAP, Reduce, and some others, where it may be that some identifiers are sent, and these identifiers may be identifiers of the station or the user. It could be interesting to look a little bit deeper into how these intersect with these requirements that we have at the end of the document. So I would like to encourage you to look at this document again, especially the last section, as it's what is new. We also corrected a couple of typos, but the main thing is the this new section, and provide feedback here on the list or to us, the authors, so that we can continue making progress in looking into the landscape and looking at what solutions are available. Let me pause there for questions.
Thank you very much, Jerome. Any questions? I don't see anyone in the queue. Comments? Then I think, I think we need to get some feedback on the mailing list and reviews. I'll try to provide one as an individual before the next iteration. So, and then hopefully we'll get some additional reviews and we will move it from there. Okay, thank you very much, Jerome. So then we can move to the next slide. Let me. Which is about the roaming experiment.
Thanks, Carlos. Can you hear me?
Yes, loud and clear.
Sorry, it takes there's a little lag with the buttons here. So this is just an update or a heads up rather for the group about an idea that has been discussed with the WBA regarding an open roaming experiment. So open roaming, as you may know, is this technology that is based on Passpoint that allows Wi-Fi to connect to a new network without necessarily providing for the user providing the password every time or requesting credentials, etc. So, but rather the authentication and authorization is done through Passpoint, just like EduRoam would work, for instance, or other scenarios where the user beforehand. So in this case, the WBA is putting in place this federation that allows multiple identity providers to use different network providers, and then the users can connect to new networks by just having an authenticated exchange with the identity provider. So this is, of course, something relevant to us because it does not rely on the MAC address randomization, and it uses both IEEE 802 and IETF standards already. So this is something that we would like to explore to see, first of all, how robust it is, and then how much we can rely on it for the use cases that we're discussing. So seems relevant to have something to try at an IETF meeting, hands-on. And for that reason, we were discussing the possibility of running it at an upcoming meeting that could be London or some other meeting. To give you an idea, this is the slide that they provided, where you have on the left-hand side the open roaming identity providers, which could be of course a service provider, but could also be a mobile operator, a cable operator, and an ISP, or some other cloud provider, for instance, or even a goods provider. So it could be your best or preferred coffee shop, or it could be the one that is hosting your information in the cloud. And on the right-hand side is the network providers which are the ones deploying the actual access points. So in the middle, we have this open roaming infrastructure that allows to exchange these credentials with 1x and then be authenticated. So for the experiment, what we would like to do is, of course, use the IETF network on one hand, and perhaps rely on IETF as an identity provider, besides, of course, existing ones. But for that, because IETF is aware and well known for the usage of the network, the access network, and also we already have some infrastructure in place through Data Tracker, for instance, to identify users. Sounds like this could be an interesting experiment to run. So anyway, just to give you a heads up that this discussion is going on, and we still have to boil a few details before we can call a go, but better to give you a heads up of this discussion. Michael.
Michael Richards on the mic. So I think I remember once we tried to do something different, but similar concept in the IETF network. And one of the things that quite reasonably someone said is, did you pass it? Did you get an ethics committee and did you get consent? And people said, oh, and then we did it again the next year, the next IETF. So just to mention, that's actually something that we probably actually have to do. And in some jurisdictions, it's not optional, really not optional. So just something not to forget that, yeah, we think we can do experiments on ourselves, but we still need to ask for consent. And we may need to actually, particularly for PII, we may actually need to have a real clear plan of what we're doing with that. Thanks. I'm really excited to do it though.
Yes, thanks. And indeed, part of the discussion was, okay, let's open up the IETF network to these providers, but then, of course, people may not trust the existing providers. So that's why we started exploring having IETF itself as an identity provider for people that don't necessarily have a relationship or want to have a relationship with the other providers. So the idea is for the same infrastructure to handle the different situations, but your point about the consent is well taken, and this is definitely something we will discuss. So thanks a lot for that. Any other comments or questions? Okay, so thank you very much.
Thank you. Let's move to the last point in the agenda. Lynn, are you connected? So I see you connected. Can you speak? Okay. Let me project your slides, and I will give you control. I cannot hear you. Can you try to speak?
Can you hear me?
Yeah, now we can. Please go ahead.
Okay, so hello everyone. My name is Lin He from Tsinghua University. Today I'm gonna introduce Savvy WLAN briefly. The title of this draft is a Savvy solution for wireless LAN. Here is the outline of my presentation. First, let's go to the background. The goals of Savvy is to ensure the hosts attached to the same IP link cannot spoof each other's IP addresses without disrupting legitimate traffic. To enable network operators to deploy fine-grained IP source address validation without dependency on supportive functionality on hosts, the Savvy method was designed to purely network-based. The service instance enforces the host's use of legitimate IP source address according to the following three-step model. The first step is to identify which IP source addresses are legitimate for a host based on monitoring packets exchanged by the host. The second one is to bind a legitimate IP address to the link layer property of the host network attachment. This property is called a binding anchor, must be verifiable in every packet that the host sends and harder to spoof than the host IP source address itself. The third step is to enforce that IP source address in packets match the binding anchors to which they were bound. Next, let's move to the Savvy solution for wireless LAN solution. This is a high-level overview of Savvy for wireless LAN. The binding anchor in Savvy WLAN is MAC address, which should be secured by .11i or other mechanisms. When the user configures an IP address, the access point and the access controller perform address assignment snooping. For example, through duplicate address detection or the DHCP procedure. Then the access point synchronizes sniffed MAC and IP addresses through cap web extension with access controller. And the access controller confirms the legitimacy of the binding entries. When receiving packets from the user device, the access point and the access controller can enforce the binding entry by filtering the spoofing packets. There are two data structures used in WLAN. The first one is the IP MAC mapping table. This table maps IP addresses to their corresponding MAC addresses, and it is used in the control process. And an IP address can have only one corresponding MAC address. Different IP addresses can be mapped to the same MAC address. The second one is MAC IP mapping table. It maps the MAC addresses to the corresponding IP addresses. It is used for filtering. A MAC address can be mapped to multiple IP addresses. Both the MAC IP mapping table and the IP MAC mapping table can be maintained separately on different devices. So a synchronization mechanism must be used between these two tables to ensure the consistency of the bindings. As mentioned above, the binding anchor used in WLAN is the MAC address, but it should be secured by .11i or other secure mechanisms. If the MAC address is unprotected, an attacker can spoof the MAC address to pass validation successfully. As for binding operation, there are three types of scenarios. The first one is static. All the static IP MAC address pairs are configured into the IP MAC mapping table with a mechanism enabled. The second one is through DHCP. The Savvy instance or devices snoop on the DHCP address assignment process between the attached host and the DHCP server. The third one is Slack. Savvy devices snoop duplicate address detection procedure or address resolution procedure between attached hosts and neighbors. There are three types of situations for binding clearing. The first one is a host leaves explicitly this access point. In this case, all entries in the MAC IP mapping table associated with this MAC address must be cleared. The second one is a DHCP release message is received from the owner of the corresponding IP address. This IP entry in the MAC mapping table and the corresponding entries in the MAC IP mapping table must be cleared. The third one is a timeout message of the access controller's client idle time is received. In this case, all entries in the MAC IP mapping table related to the MAC address must be cleared. Sorry. So the core of the source address validation in wireless LAN is to look up two tables, MAC IP mapping table and IP MAC mapping table, to check whether the corresponding entry exists. Due to time constraints, I won't extend here. There are two deployment scenarios. The first one is centralized wireless LAN, which consists of feed access points and access controllers. In this case, there are two types of filtering cases. The first one is IP access point performs filtering. In this case, access controllers maintain IP MAC mapping table, while access point maintains MAC IP mapping table and perform address snooping. The second one is access controller performs packet filtering. Access controller maintains both MAC IP mapping table and IP MAC mapping table, and they perform both address snooping and packet filtering. In this case, so all the packets must be forwarded to the access controller first. This slide presents a mobility solution. When a user moves to another access point, the foreign access point will first request the IP address corresponding to the MAC address. Of course, there may be synchronization between access controllers. The second one scenario is that autonomous wireless LAN, which consists of fat access points. Fat access point maintains both MAC IP mapping table and IP MAC mapping table, and performs both address snooping and packet filtering. So how will MAC address randomization affect WLAN? In wireless LAN, random MAC addresses are mainly used for discovering wireless networks, accessing networks, and communicating. We analyzed the impact of a MAC address randomization on a savvy WLAN, and in these cases, and found that the anchor point, binding anchor of the savvy WLAN is stable during one access. And the savvy for wireless LAN function will work well. So the next step, we are wondering, so where to promote this work? Maybe there we can promote this work in Madinas or inter-area working group, and we solicit comments under. The next step is we will solicit comments and refine the draft. Okay.
Okay, thank
Any
you.
comment? Thank you.
Thank you very much. Any comments? Let's see, Eric.
Three.
Sri Gundavalli, Cisco. I have a clarifying question. I did not read your document. So can you go back to slide 6?
6.
Slide 6.
Okay.
So again, I'm trying to understand, right? Where exactly is the validation that's happening? So if I understand correctly, you're using CapApp extension to carry something which says that, okay, first thing you're snooping the DHCP transactions or DAD packets. Based on that, you're forming a relationship between the IP address and the MAC address. And that information, you're pushing it to the access point or CapApp. Is that my understanding correct?
This information is maintained, can be maintained in access point and access controllers.
So if there's another, let's say an attacker who is trying to use the same IP address, where do you do the enforcement? Is it on the AP or on the AC?
Usually we can enforce it in access point. But if you in the centralized wireless LAN, we can enforce it in access point. The second, but you can also enforce it in access controller. In the autonomous wireless LAN, you can enforce it in fat access points.
But in the autonomous mode, your DHCP transactions are not coming to the access controller. So how do you know the state?
So you mean the DHCP packet do not go to access controller?
So it depends on the mode. So the question is the assumption that all your DHCP
Sorry to interrupt. I think for the sake of time, maybe we need to move that discussion to the mailing list because we still have some questions from Eric
yeah, that's a fair
and JC.
point. Okay, all right.
Eric Klein. On slide 7, the next slide.
Okay.
Thank you. Do you support IPv6?
Yes,
And if so,
both IPv4 and v6.
okay, so with what I think the third sub-bullet of the first bullet, how do you support IPv6 anycast addresses?
Anycast address.
RFC 4861.
So you mean just anycast addresses cannot be supported here? So your question is how Savvy WLAN support the anycast IPv6 addresses?
Yeah, I was wondering because you can have the same IPv6 address have multiple MAC addresses if the override flag is 0.
This is a good question.
It's doing snooping, and I'm assuming. Sorry, this is to Michael. It's doing snooping, right? And I'm assuming it's populating some table.
Sorry, Michael, the queue is closed.
Well, yeah. Maybe this. I'll just take this
So
mail.
I don't think it's supported as a source because he's got to snoop the source address, not the destination address. I think.
Yeah. It snoops a source address.
Thank you.
Okay, Juan Carlos.
Hi. I was just trying to get to the questions that are being asked at the end, whether this is something that should be discussed in Madinas or Interia. So at the moment, it doesn't seem to me clear that this is in the charter of Madinas. Of course, it is relevant to the discussions we've been having, but because we are right now more at the survey stage and gap analysis, I don't think that we can dig into this space, this solution space right now. So I would rather hear a discussion going to the mailing list before we derail too much the scope that we have right now.
Okay, thanks.
Thanks.
Eric Vinken, sorry for joining the queue once it's closed. But indeed, I do not see this draft as becoming or fitting the charter of Madinas. So the default thing most probably will be Interia or perhaps a dispatch.
Okay, thanks.
Okay, thanks. So let's then quickly move to the next steps. So I would like to, in these 2 minutes that we have, or 3 minutes, I would like to get some volunteers for reviewing the drafts that the working group drafts that we have. I already volunteered for reviewing the use cases and requirements. I think in order to move along, it will be good to get 1 or 2 reviews per document. So any volunteers here, of course, we will be asking that on the mailing list. I see Michael going to the microphone.
Michael Richardson here. I'd like to suggest the chairs we have a virtual interim before London. And that, yeah, we need to do reviews on the mailing list. We made progress. We haven't really done anything since the last IETF, so I think that's a really good solution. I've read them all, and I would like to have a bigger conversation about what's in them there.
Okay, thanks. We take note of that, and we will discuss with AD and see next steps. But that's good feedback. And Jerome, if you are in line, I think one thing we can do meanwhile is that if you can review the other charter item while I review yours, I think we can benefit from some cross reviews in the meantime, if you don't mind. And JC, any additional comments before we close in these 2 minutes?
No, Jerome, do you have something to say?
No, will do. Thank you, Carlos. And yeah, please review. Well, a great idea to have an interim in between. We may continue augmenting the draft in between, but input will be very, very welcome.
Okay, thanks.
So maybe the very last comment, I think Michael's point about an interim is a very good one. I'm just wondering, after the summer vacation period, September, October, early October probably is a good time frame. But we can discuss this on the mailing list.
Okay, so if there are no more comments, we can close the meeting. Thank you very much for attending both locally and remotely. Thank you.
Thanks, everyone.
Hey. Hi, how are you?